Welcome, everyone. My name is Crystal Hopper Myers, and I run our STEAM Pathways program here at the college. I get the great opportunity to be able to work alongside all of these amazing professors. We have many of them in the room today. We also have some awesome student researchers. They're doing great things. We're actually traveling this week to Oregon State University to their Oregon NASA Space Grant Consortium symposium to present some research. We had a team, it's actually our Fossil Point team that we got a faculty research award, which is led by Dr. Wynn McLaughlin. And this was kind of a neat project that made where we had a variety of different sciences happening all at once. So we had our physics professor and biology and chemistry and geology all working together. So it was pretty cool. On top of that, not only are our faculty research award team being recognized and being able to present the research, our STAR Award winners are also being recognized, even though they don't have to present there. We actually had 3 that was SWOCC that received that. And that was for, again, a variety of sciences from astrobiology, psychology. So we've got a lot of things happening here, and we appreciate the community supporting us with all that we do. If you have not had a chance to sign in over here, if you have not had a chance to sign in over here on the paper, if you would on your way out, it kind of helps us track how many people that attend these events. As you can see also, we have a live stream happening and it is recorded, so you can pull it up on YouTube later. We have a watch party at our Curry campus happening as well. And tonight our guest has said that it was okay if you would like to ask questions throughout the talk. So I will have the microphone, and if you just want to raise your hand, I'll walk around and get to you as soon as I can. With that said, we have lots of things happening, planetarium going around the community. If you haven't had a chance to see that, that's really exciting. And other events for K-12 and community outreach. So please just jump on SWOCC.edu, or we have a really active Facebook page for SWOCC STEAM Pathways. You can follow that. And with that said, Dr. Wynn McLaughlin, our geology professor here and paleontologist, would like to introduce our guest.
And I'll do 2 more quick shameless promotions. March 11th, I got the date right? Yes. We're going to have a really awesome talk on sea otters. So bringing sea otters back to Oregon, what's going on with that? What's the status of that? So that should be really cool. That's already scheduled. And then I have just lined up the next geology speaker, although I don't have an exact date. So stay tuned. It'll be on how do we know what's underneath Yellowstone. So basically Yellowstone's plumbing and why you shouldn't actually be afraid. The word crystal mush will be used a lot. So with that, I would really like to be very excited to welcome one of my good friends, Patrick O'Grady. Pat was the poor soul that was stuck with me for a lot of grad school because I was the weirdo that really liked bones. And even being in paleontology, most of my lab was like, we like bones that are rock and not bones that could still have squishy bits on them. And this is the guy that taught me how to make them into pretty nice bones that students will touch and not ones that they run screaming from. So with no further ado, because he can introduce himself for the rest of it besides my terrible introduction, I'd like to bring up Dr. Pat O'Grady to talk about why Oregon has some of our coolest history for really arguably all of North America, I'm going to say.
Thank you, Wynn. Can you hear me okay? Is this coming through all right in the back? All right. So tonight, excuse me, I'm going to talk about a site called Rimrock Draw Rockshelter. and it is a location over, I'll show you in a map in a minute, but it's a location that you can see here on this image that consists of a very modest rock wall, a basalt wall that's about 20 meters in length, and it faces northward. So the prevailing winds that are coming out of the southwest are blowing sediments over the top of the rock shelter and into the shallow alcove at the base of this rock wall. In this picture, you can see the rock rim that is the rock shelter itself. You can see a wide channel that goes between the rock wall and this deal right here. This is an excavation pit that's covered up. But there's a stream channel that runs between those two locations. There's a terrace above where that excavation is on the north side. There is a rock wall that is somewhat protected from the stream channel. So water went right through this wide open desert expanse, as you can see it right here, and was the primary reason for people being at this site. So I've got things divided up into just real basic categories. I'm going to start with water and move into different parts of the archaeology and the geology of the location. So you'll see headers that say things like water, wind, gear, that sort of thing. And that's just to help keep me on track with what it is, the points that I want to get to. So let's get started here. So here's the location of Rimrock Draw Rockshelter, that square that it's located in, that rectangle that it's located in, is actually Harney County, and Rimrock Draw Rockshelter is in the northwest portion of Harney County, close to Deschutes County and Lake County, and then just a little bit to the west and north of those two big lakes that you can see that are Malheur and Harney Lakes. So if anybody has been to the Malheur National Wildlife Refuge, you know where those are. And this location is to the north of that, out in wide open sagebrush desert country. Here's a picture of where the rock shelter is located. This is from the first time we laid eyes on this place in 2009. And you can see that it's a relatively 20, 25 feet high rock wall. It's a very modest, sheltered area. The cattle actually love this place. It's a great windbreak for the cattle. So when we first came to this location, we found that it was bare ground, it's surrounded by sagebrush and with a rock wall above. So we were working at a site down the road that was what's called a Clovis site. Clovis is a very early type of a stone tool found throughout North America and into South America. And so we were working at one of the 10 known Clovis sites in Oregon, about 5 miles down the road from here. And we were getting support from Scott Thomas, who was the BLM district archaeologist at that time, and he was my partner throughout the process of excavating this site. So we were working down the road. Scott was bringing us supplies that, we would call him up and say, Scott, we're out of this, we're out of that. We need the porta potties to taken care of. We need more water. And Scott would always come down and bring us whatever we needed. And he got pretty sick of that over time. So he was looking around and thinking about things that he would like to do as an archaeologist in the course of taking care of us as a needy archaeology field school. So Scott saw off in the distance that there was this shadowy rim. He could see it from the main road that he was driving down, and he thought, well, I'm going to pull over there and take a little time for myself. And Scott wandered down, and as he was approaching this location where this rock rim is, he started to notice suddenly that there was obsidian chips on the ground. There was first a few, a sparse scatter, 5 or 10, 20 or 30. As he started to get closer, he could see that there were hundreds of black glass obsidian chips on the ground surface in a radius surrounding this little rock rim. And so Scott knew there was a site there. and that part of it was exposed on the surface. But what really caught his attention was the fact that as he was standing down here in this exposed area at the base of this rim, there was nothing on the ground surface. So in an erosional setting, he could see that there was thousands and thousands of stone tool fragments, obsidian chips from making stone tools, lots of stuff like that. But when he was standing down here, there was nothing on the ground surface. And that was very exciting to him and to me as well, because that indicated that the site was, or the area around the rock shelter was undisturbed. It hadn't been excavated or looted, anything like that. And so the evidence surrounding that rock shelter said there was a lot of stuff there. So in 2009, Scott discovered the site, and then since we were still working down at Sheep Mountain down the road, we started making plans to go and maybe do some testing at the location. But first we wanted to have pedestrian surveys done of the ground surface. And we were working with a volunteer group called the Oregon Archaeological Society. These are citizen scientists. The club is based out of Portland, but there are members throughout the state and beyond. And we have employed them as volunteers on lots of different kinds of projects on our archaeological work. So they will go out and do pedestrian surveys and look at places we're interested in. They help with excavation. The Oregon Archaeological Society has literally contributed tens of thousands of hours of labor to our work out here at Rimrock. They're a very important part of what we do. So in between 2010 and 2011, we had the Oregon Archaeological Society doing surveys, and they would come back down the road to Sheep Mountain to see us at the end of the day. They usually spend about 2 weeks every year out helping us. And each time they came back, they were bringing back these very old types of stone tools that begin around 7,000 years in age and extend back to 13,000 years in age. And it was almost exclusively those types of stone tools that they were coming back with. And so that was very exciting because it told us that in a place where we have archaeology that goes from homesteaders 100 years ago to Paleo Indians, or what we now call Paleo Americans, 8,000 to 15,000 years in age. So they kept coming back. They kept bringing these cool artifacts, things that look like this. And I'm going to pass this around because this is something that we see on a regular basis from the site. Usually not quite this large, but this is a classic stem point here. Stem point doesn't have notches like some of the more recently made points. Instead, it has a big blade, it has shoulders, and it has a stem that's either tongue shape or square base. It can be lots of different forms, but oftentimes they take this form. So yeah, and just pass that around. Don't drop it, please. So anyway, that's the kind of stuff that they were coming back with. And then, so as we were finishing up at Sheep Mountain, and they were doing 2 years of surveys out there, in September of 2011, we decided to go out and do 2 weeks of test excavation. That was a very successful outing that I'll talk about more here in just a little bit. But after the 2 weeks of testing, we decided we were going to do 6-week-long archaeology field schools for the University of Oregon. And we continued doing that for a number of years, finishing up in 2023. So in total, we've spent 58 weeks, just over a year of excavation and field work out at Rimrock Draw. And it's been some of the best times that I've ever had as an archaeologist. And for the students that we were bringing out there, it was exceptional because students don't oftentimes get to train on a site that is this complex and this ancient. So we were giving students an opportunity to work at a place that they probably would not likely see ever again in their careers. So to get them started off on this foot it was really great. It was a lot of fun. So here's what the site looked like after we'd been there for a few years. We started excavating in earnest in 2011. This was in 2016. And so, excuse me, we've dug quite a bit close to the rock shelter. You can't see the excavation pits too well because they're deep in the shadow here. But you can see the sandbags. And the sandbags are filled with all of the dirt that we excavated from the units and passed through screens to look for stone chipping debris, stone tools, bone fragments, things that are associated with an archaeological site. So all the sifted stuff went into those sandbags, and then after we were finished excavating, they all went back in the holes to help protect the excavation blocks until we came back the following year. So one of the things that was the best kept secret was to make sure that students never found out about the sandbags until they had paid their money for field school and were already out there, because not only did they have to put the sandbags back in, but they had to take them out. And so at last count, we were over 10,000 sandbags at this site. So this is just what some of the radiocarbon dates are. These are all AMS, or Accelerator Mass Spectrometry radiocarbon dates, which means that you can take a very small piece of carbon from a variety of different organic objects and precisely date it. So these dates I have segmented in to two different sets, actually. So the ones at the top of this chart, or at the top of this table, are all plant dates that are between 4,500 and 10,000 years in age. Plants and, or actually these are plants and sediments. And then, so we know that there's a bunch of different organic materials, plant and sediments that have been dated to 10,000 years that are separated from the oldest dates at the site by a layer of rockfall. And then down below the rockfall, we have dates that begin at 12,700 years in age and go to 18,500 years in age. And those are on herbivore teeth. So we have bison, camel, and horse teeth that have been identified from the site. And we have just a top-notch radiocarbon dating expert named Thomas Stafford, who's done all the dates. And he's getting radiocarbon dates that are on bison and horse and camel tooth enamel that so these go in calibrated terms, 18,000 to 18,500 to 18,000 to 17,000, and the variation, or the standard deviation on these dates can range between 30 and 45 years. So these are very precise dates with a very limited standard deviation. Some of them get back into the 25-year range. So the whole purpose of showing this table is to show you that in terms of bracketed sequences of radiocarbon dates, we have more recent dates from 4,500 to 10,000. We have a layer of rockfall that buried an old surface, and on that old surface, we have dates that range between 13,000 to 18,000. So the confusing part of this, as you look at it, is that over here, these are the conventional dates. So these are the dates as the samples come out of the instrument, and then what you're seeing over here are those dates as they're converted into calendar years. So the radiocarbon years are different from the calendar years because there's fluctuations of carbon in the atmosphere. And those fluctuations on the radiocarbon dates are compared to samples of tree ring samples that have very precise, almost to the year calculations on them. So they calibrate the radiocarbon dates against the, turn those into calendar years. So, oops, wait a minute. So a date of 14,975 radiocarbon years plus or minus 45 equates to a calendar date of 18,007 to 18,361. So when you look at these, I prefer to talk in this setting about calendar years, just because it's easier for people to understand who may not have the background on dealing with radiocarbon dates, but both are appropriate.
Patrick, can I interrupt you real quick?
Yeah, of course.
Can I just, before we get too far, can we go back to the map as to where the site is? And can you orient me as to where the Paisley Caves are in comparison to Rimrock? Because I also, if I'm correct, that's another site that's close by that also has older carbon dates from it. Is that
I'm
right?
sorry, say that. Oh, Paisley Caves.
Paisley Caves. Can you
Paisley
show me on a
Caves,
map?
yeah. Let's see here. So if you go from Rimrock, which is roughly this giant triangle that's the size of New York City, basically, and go down here to the south end of Summer Lake, that would be the location of Paisley Caves.
Perfect. Thank you.
Uh-huh. So confusing stuff, the dates are a little bit confusing, but basically I'll be talking for the most part about calendar years and not radiocarbon years for this next little while. So the questions we've been asking about the site are real basic, because when we started, we were working from a completely unknown excavation, a completely unknown spot on the desert surface, and trying to work our way back through time just to see how old the site is. And so we want to know how people use the rock shelter, how old it is. Archaeologists always want to know how old something is. Was the site subject to erosional processes, or are these depositional processes that have been at work at this place? And so erosional processes can result in materials gathered on a surface, like the stuff that's all around where the rock shelter is. That eroded surface, that rocky surface, is all the stuff that was sitting up there that may have been sitting on a layer of dirt, but it all got blown away and it just settled on the rocks themselves. In the rock shelter itself, we didn't think that was the case, so we wanted to know what was going on there. And then what was the paleo-environmental context for the site? So what kind of a landscape was it at the time that people were there? And there's a whole set of dates down there that I'm not going to go into, but basically we've, based on our radiocarbon dates, we know the site was occupied between about 18,000 to about 7,000 years in age. So water. This is a picture that's taken on top of the rock shelter. I don't like to, I have a bad case of vertigo, so I don't get real close to the edge. But the edge of the rock shelter, when you're standing above it, is right there. And there's an old stream channel that I pointed out previously that goes this way. Downstream is this direction. It curves down around that basalt rim and then out into an open expanse that feeds into Silver Creek, and then into Silver Lake, and then into Harney and Malheur Lakes eventually. But that old stream channel hasn't carried water in a long time. So why would anyone want to live in a desert? Well, because at the time that people were here, it wasn't a desert. It was a much different sort of a landscape. And Tom Stafford, who was the person that did our radiocarbon dating on the Pleistocene animal, tooth enamel, was out there with us on a regular basis, doing sedimentology and also collecting samples for radiocarbon dating. He tended to take notes on his hands when he was explaining things. So if I wanted to remember the notes to put into my notebook at the end of the day, I would take a picture of his hand every day and then try and transcribe that stuff onto my notebook. But Tom, as he tells it, trenched his way across Texas when he was doing his PhD and master's research and studying sedimentology. So getting him out there to do the sediments as well as do the radiocarbon dating was a great thing. And so Tom's idea was that there's a 3-part sequence at the location, and this is in one of the trenches that is out a little bit from the rock shelter. You can see there's a clear separation between the deeper, darker sediments and the lighter stuff above it. So what's up atop from the surface down to that contact is windblown sands and silts. There's a layer of Mazama ash that's sitting there. Part of it is reworked, and it's about, depending upon where you are, the Mazama ash is anywhere from 1.5 feet thick to a couple of centimeters thick. So it varies, but it's always on top of that dark, marshy, organic deposit. So below that marshy deposit is high energy boulders, cobbles, gravels from flood events and stream transport. So Mazama ash, if you are all familiar, I'm sure you all know this already, but if you have been to Crater Lake, which erupted about 7,600 years ago, the release from that eruption is a thick layer of fine, gritty, glassy volcanic ash that's spread basically from the eruption northward, a little bit southward, but eastward as far as Montana, and then went into suspension and is found at other places around the world. So we know when we see that dark sediment and we have the volcanic ash sitting on top of it, that if it's not been cut or truncated, which we haven't found anything like that yet, that everything below that ash is older than 7,600 years in age. So it's really handy to have that out there. So the stream channel we know was active at least in up until 13,000, or the last big event in the stream channel was 13,000 years ago. And then there was a lesser amount of water flowing through the area, and the transition from a high, fast-flowing stream. These are boulders from in the stream channel that came out during trenching. It's essentially what we can see here is that there's a piece of bison tooth that we've dated that was at the contact between the bedrock and the stream channel, or between the stream channel and the marsh deposits at 13,000 years of age. And that we know that the last big event that occurred in that stream channel's life was about 13,000 years ago. So on top of that high velocity stream that was flowing through there at one time, there's what's commonly called a cienega, or kind of a slow water, quiet water sort of an environment that's boggy and marshy. Great place for people to gather quite a few different types of plant and animal resources. And so we have the high velocity stream, we have this marshy deposit that's thick and very rich and very dark colored. And then we have the Mazama ash on top of that. We know that there was at least one spring that was on the other side of the stream channel from the rock shelter that contributed water on a regular basis, because when we were out there working in 2021, which was the height of the drought season, there hadn't been water in there for ages, and we hadn't seen any water in our excavations to date. But when we were looking at the deposits on the north side of the stream channel, we could see that there was black clays that were coming from higher up on the side and coming down towards the marshy area, which indicated that water was flowing down from that location. There was probably a spring there. So when we started excavating in 2021, one of the students pulled up a obsidian knife that was laying on the marshy deposits, and water started welling up underneath it. And that was the first time we'd seen anything like that, suggesting that it was a spring. And then we were finding stone tools like those that are noted above there, stem points like that one that's being passed around, foliate points, scrapers, and then herbivore tooth enamel. So these things were starting to appear over on the north side away from the rock shelter, indicating that they were concentrated around what was a spring deposit there. So where's the water coming from? Well, we know that right here is where the site is located. During the pandemic, I couldn't have a field school, so I spent about a month out there by myself, just walking all the stream drainages and taking a look at how water was coming into the basin. And we have three big playas out there: Wheatgrass Lake, Hay Lake, and Rimrock Lake. And just looking at the topographic elevations around those and in between, we have an area that would, if it were blocked off, would have created a pretty massive lake just above where the rock shelter is, and the outlet would have been right here. There's a ridge right here that's been truncated in recent times, but right here is the edge of Juniper Ridge, and over here is the edge of the rim that would have gone like that. And so there's always been an outlet right here located that would have gone by Rimrock Draw Rockshelter. And people could have gone up on that ridge and looked over the top and looked for animals, birds, things like that, and been out of sight otherwise. So we did some coring of Rimrock Lake, and the oldest dates that we have on Rimrock Lake, calibrated dates, are in the 18,500 to 18,300 range. And at Hay Lake, we have 19,200 and 19,540 as the oldest dates. So the development of those playas, those big, what are now dry lakes, above Rimrock, were about the slightly before or about the same time as the site at Rimrock Draw was being used. Any questions so far? I mean, I'm just kind of throwing a lot of stuff out right now and trying to give you different bits of context for what happens a little bit further down the road. So, yes. How long are these lakes? It's okay.
How recently did the landscape change, and did it change very suddenly? Like, could you go back 1,000 years and find lots of lakes, more oases, and
Well,
little...
I'm glad you asked that, because I'm going to get right into that.
Well, then carry on.
So we know there's what appears to have been a big lake up above where that rock shelter is located. There was water that flowed through there and carried some pretty heavy sediments, as well as boulders and cobbles, into the area in front of the rock shelter. So, and we think this is the closest case for where that was. So 19,260 at Hay Lake, 18,310 at Rimrock Lake were the oldest, deepest playa deposits. So dirt. This is from a big trench that we dug in 2013, cleverly named 2013-1. And what we can see here in this profile is windblown sediment that is from the surface down to this line that I've drawn, located where the Mazama ash is. There's marsh clays underneath, and then there's boulders and gravel from stream transport. So the boulders and gravel suggest there was a lot of water going through at a pretty high rate of energy. The marsh clays are not as rocky, and actually not very rocky at all, and heavy with clay and dark material, organic material. and then they're truncated, and then there's a layer of Mazama ash from the eruption that formed Crater Lake 7,600 years ago. That Mazama ash is overlain by reworked Mazama ash that's blowing off of the playas and the landscape around that goes up about like this. You can see right here. It's kind of cut up by some burrowing right here, but it's in there. And then after that Mazama landed, we have nothing but sand and silt and volcanic ash blowing in from other places. We don't have any channeling at the site, but we have this layer of desert conditions, sort of sediments that say that water wasn't there after Mazama landed. So the primary Mazama is sitting on top of that black Cienega deposit as a very fine bead. So you can see it right here. We chunked out a sample, samples above and below, and then a separate sample of that. And it goes like that. And where the clay or the heavier clay deposits are in the material underneath it, you can see that ash, when it's exposed to the air, starts to separate. It cracks and separates from the organic down below. And then you have the reworked Mazama up above. This is a picture that turned out terribly, but it's just another view of a trench further downstream that is Mazama ash, shows the Mazama ash and the same sequence of older marshy and stream deposits and windblown or aeolian sediments up above. This shows the location of bedrock, and there's the location where we got that 13,000-year-old bison tooth. These are the black Cienega or the marshy muds, and then the Mazama ash and some diatomite up above it. So we've got a combination of Mazama ash, we've got diatomite or organic glassy plant deposits, and then the windblown sediments up above. And then inside the rock shelter, we have those same sediments, but they're more muffled because people were using the rock shelter area and walking back and forth and mushing things up a little bit. But what we can also see inside of the rock shelter area is that we have rocky deposits. So it looks like there was a rockfall that occurred at one time inside the rock shelter that separated the older sediments that have the stone tools and chipping debris and herbivore tooth fragments all mixed together, and then rocky deposits, marshy deposits, and then this windblown sediment. So it's just a reiteration of what I was showing outside of the rock shelter, inside of the rock shelter, showing that the sediments are fairly consistent. But down below, they've been protected by this rock layer for a longer period of time. So I am going to talk here about where we're finding those tooth enamel fragments that we dated. So the first discovery was in Unit 2, which is a 2 by 2 meter square that was dug from 2011 through 2012. And Unit 30 that has been dug since then, and we finished our last excavations there in 2023. And then Unit 18 and 19. These units have bison, horse, and camel teeth in them. These units have bison and horse teeth in them. So they're a little bit different, but where the bison teeth and the camel teeth are being found is over here. And in units 18 and 19, it's over here. So we have about 3-4 meters of separation between what we see over here and what we see over in units 18 and 19. And the reason I'm pointing that out is because as we excavated down through that material to get to the deepest deposits where all the tooth enamel and the stone tools are located, we can see that the sediments and the depths are consistent across the site from over in Unit 2 all the way over to Unit 8. So there's 3 or 4 meters, close to 5 meters in some cases, of sediments that match up right at the back of the rock shelter in terms of depth of the sediments and what's in them. And that's important because that indicates that those sediments have been protected for a long time by that rock layer. So what are we finding in the deposits? This is important because we know that after the eruption of Mount Mazama, we have that layer of Mazama ash that's sitting there, and we have nothing but sand and silt, volcanic ash that has blown in and is on top of it. So there's things turned into a desert-like condition after about 7,600 years ago. And when we look at the archaeology or the stone tools that we're getting from this site, we can see in a really interesting way that the presence of the certain types of stone tools matches up to that switch to desertic or xeric conditions. So diagnostic artifacts are one of the best ways, the easiest ways, I should say, of identifying how old a site is, because if we walk up and see a stone tool that has notches on the sides or notches on the corners like these, we know that those date from about 7,000 years, 7,500 years forward. And the most common types of stone tools that we see in the desert, if you were to take a walk over in Eastern Oregon and look on the ground and spot a stone tool or two, or 7 or 10 or whatever, probably 7 out of 10 of those stone tools would be a notched stone tool, corner notched in the Elko variety, as we call it. Those Elko points were carried by people because there was a lot of water and a lot of resources scattered across the desert during a wet period in the middle Holocene around 5,500 to 3,500 years ago. So everywhere, Elko points are everywhere. And at this site, we have 6 of them. And so that shows us that people were coming through there very infrequently, but not after about 7,000 years ago. And then we have northern side notch that date from 7,500 forward, but at this location, since we have northern side notch, but we don't have Elkos, the northern side notch we're seeing are on the early end of the range, 7,000 years ago or so. We have cascade points, stem points, a whole set of different types of points that suggest that people were here before 7,000 years ago, and at least as far back as 13 to 15,000 years in age. So over 100 of these diagnostic types of points and flaking and artifacts with certain flaking characteristics that suggest very early times, and hardly anything after 7,000 or 6,500 years ago. So here's another point. This is called a Haskett point, and points like that are part of the Western stem tradition, or stem points in that 7,000 to, in this case, 7,000 to about 13,000 years in age. This is a replica, but it's very well matched to the ones that we're seeing at the site. Yeah.
Proximity to glass buttes had a lot to do with how many fragments of things there were.
So the question is, how Glass Buttes, which is about 15 miles away, does that have something to do with why people were at the location? And I think Glass Buttes is very important. But what Glass Buttes, because it's a massive obsidian source. It's just you go out to mile point 77 on Highway 20 coming from Bend, going towards Burns. You take a right, And you go up into Glass Buttes and it's just nothing but obsidian up there. It's an amazing place, and people used it for making stone tools for many, many thousands of years. And in this case, I think it is really significant that Glass Buttes is there, but no one was showing up at this site, which is so close on a direct travel path after 6,500 years ago. It makes sense that if that source is there and there was a reason for people to camp here, they would have been here at this time. But there just wasn't any water. There wasn't a reason for people to come to this site. And they didn't after 7,000 years ago. So it's a great question. I'm really glad you asked that. Another one?
Curious about the stark division between the Mount Mazama site. Seems to be a major climate change. Serendipity, or
I think that that's something that we point to, but it's for others to make those connections, especially geologists. So I think that there was some sort of a seismic event, something that happened that disrupted the hydrologic system that fed water into Rimrock Lake and into Rimrock Draw. But I know better than to tread on the ground where geologists, they know so much more about the systems out there than I do that I don't even. That's why I have Tom Stafford out there, is because he says there's no such thing as a geoarchaeologist. There are only geologists, and I agree with him. So anyway, here's some of the stem points like that one I just handed around. This is a big fragment of one of those right here. These are all stem points in that, say, 7,000 to 15,000 year time range. And we have a lot of them at this site. The ones that we see most commonly are broken. So people are coming to this place and they're popping the old points off of their atlatl darts or their spears, and they're replacing them with other points that are made from other types of obsidian, some of which is Glass Butte. Here are some more of those stem points in different varieties. These are more square-based here. But this is just to accentuate the fact that we have lots of stem points and not much of other types of points at the site. The other thing that we see in the older deposits underneath the rockfall area at the site are very specialized gravers and spurred tools that tell us that people were engaged in some crafting projects that are different than we see at a lot of other sites, and they're using a very high quality cryptocrystalline silicate or chert type of a stone to punch holes, make compass circles on wood or bone. This one is pretty spectacular. It has a concave scraper on this side. It has a convex scraper on this side. It has an engraving tip here. It has multiple engraving tips here. These are the kinds of stone tools that you would expect to see in the hands of a craftsman, specialized sorts of work here. And these are not the things that people carried on a regular basis. The fact that they're made out of out of chert, like this stuff here, tells you that these are made for very durable projects. They're hardworking sorts of stone tools. Okay, I got to speed it up here a little. I just looked at the time and I'm getting into trouble.
I had a couple of, hold on one second. I've got a couple of comments online. I don't want to forget about them. Couple of people just said hello. So hello to you all online. We did have one comment from Al Hart that was inquiring about touching sacred native artifacts and the legality of it. If you had any comments on it.
It's a very important topic right now. As a matter of fact, there's a thing called the Native American Graves Protection and Repatriation Act that was enacted in 1990, and it was to address concerns about the handling of human remains and objects of cultural patrimony or things related to that, to those human remains. And what became apparent in recent times is that what was supposed to happen in 1990 in some instances still hasn't happened today. So last year there was a thing called the final rule that guaranteed or demanded, in a sense, that Native American tribal people are more involved in the activities that are going on their landscape and touching artifacts. You know, we are much more involved in consultation now, and we should have been doing a better job of it a long time ago. I worked for almost 20 years for the Museum of Natural and Cultural History. And one of the things I was proudest about that institution is that tribal engagement has been a part of what we have done at the museum for years. And it's an important part of what we've done. So there's consultation that occurs, and that's something that's important to federal agencies, but it's just really become important to have more engagement from Native American people in whatever we do out on the archaeological projects and in handling artifacts and things like that. So it's something that is important to archaeologists who consider themselves anthropologists too. And it should be important to everybody, but it's been slow to implement. And so the final rule was put out in a more forceful fashion asking for those things to occur. So I'm not Native American, but I do seek counsel and guidance from tribal members.
Thank you for that.
So I showed you some chert stone tools that just a minute ago that are very high quality tools. And this is another one that I wanted to point out to you as well. This is what's called a chalcedony, or what I call a chalcedony. It's a translucent type of chert or cryptocrystalline silicate that is not banded like agate. It's a more high quality material. It's translucent. You can hold it up and look through it and see light as you can. This is a piece of that same stuff, I think, that someone gave me recently. But the important thing about this is that this was found in a very old deposit at the rock shelter, and it has that same sort of Swiss knife sort of quality to it, where it has a convex scraping edge here. It has a flat scraping or cutting edge here. And on this side, actually you can see right here, there's a sawtooth edge here that's been notched on opposing sides to create a highly durable saw for cutting wood or bone or something like that. You can see it actually here too. And then another thing that we're finding out at the site that suggests that people were using the site that were coming from lake settings are crescents. And crescents they're shaped like a crescent. Here's one here. And these are very specific tools. We find them between about 7,000 and 13,000 years ago, and they're usually on the edges of shallow shorelines. So when you see those, you know that there was a big lake somewhere nearby. And we have them on the surface at Rimrock Draw, and we also have them in the excavation. So people who were carrying these to that site were coming from a lake that was close by, because usually you always see them right there on the lake. And I'm going to pass this one around too. This is a real one. So this one, when you hold this, it's at least 7,000 years old, and it may be close to 13,000 years old.
Sorry, I think I just misheard. Did you say that you were finding these on the surface as well for surface excavation?
We were finding them on the surface when we were doing.
That you have deposits that, right? So do you have site disturbance where you're finding them on the surface?
Well, and that's a great question, because I talked about this right at the beginning, but I haven't gone back to it, is that when Scott walked up to that site, he started to walk into an erosional surface where there were many thousands and thousands of flakes and stone tool fragments and stuff like that. So the site all around where the rock shelter is deflated. It's an erosional surface, but because that rock shelter is where it is and it's north facing and the prevailing winds are coming from the southwest, sediments are blowing in and on top of the deposits there at the rock shelter. So you see those near that stream and near the rock shelter, you have those deep, massive layers of sand and silt, and then the stuff underneath it. All that's been protected because it's on the leeward side.
So if I understand you correctly, there are parts of the site that have been
Wind blasted, yeah.
you've got surface where you don't have that deposit. So
Yeah. And that was, right. And so we knew that a lot of the site was erosional, but we weren't sure if the portion of the site that was right at the base of that rock wall was ever eroded, or whether it was depositional, whether stuff just kept coming in and settling on top of that. And what the work that we've done there over the course of the past 12 or 13 years has shown us is that it appears to be a depositional environment. And we have those big layers of those 3-part setting of layers right there. So crescents. And then this is a map that shows where the obsidian that we're seeing at the site is coming from. So obsidian has a geochemical signature that varies from one source to the other, and it's very distinct. So if you have a X-ray spectrometer to do the work, you can look at the fine or the rare mineral content of obsidian from one source to another, and you can distinguish it pretty clearly from one place to another. So when we were looking at the obsidian and sent it up to Northwest Research Obsidian Studies Laboratory from this site, Rimrock Draw Rockshelter, we were seeing that the majority of the obsidian is coming from about a 50-mile radius around the site, which includes Glass Buttes up here, Round Top, which is part of the Glass Butte system, China Lake, Wagon Tire, just a whole bunch of them real close by. And then people were carrying some obsidian from Venator, which is over here at the north end of Steens Mountain, Coyote Spring in Nevada, Beatty's Butte, which is down by Guano Valley, Alturas, fine grain volcanic, Coghlan Butte, which is over by Paisley Caves. And then from Klamath Country, we have Silver Lake, Sycan Marsh. So obsidian sourcing is really cool because it tells us about where people are coming from, where they're bringing those points in that they're using on atlatls and spears. They're dropping those points there and replacing them with new ones and moving on. And this is the pattern that shows where those people are coming from. I love obsidian. This is the greatest thing ever. So plants. We know that the deposits at the rock shelter, there is sagebrush, rabbitbrush, and juniper throughout, used as fuel wood. That makes sense. Anytime people are going to stop and have a little camp there, they're going to use those easily available sorts of plants. But in the fire pits that are down deeper, that are older, they contain all of the fuel woods that we expect. Plus they have medicinal and utilitarian plants and edible plants that include willow, serviceberry, chokecherry, all of these. Bulrush, wapato, Indian potato is what that is. And unknown hardwood. So if you're down by Paisley or down by Lakeview and you're passing through Shiwakan Marsh, Shiwakan is the Klamath name for Wapato, and it was an important plant. And we have in our forests, we have those plants that shows us that people were using those very specifically with certain types of plants, and we can date that stuff. So we have burned bulrush seed from about 9,500 years. Wapato seeds that are 10,000 to 9,990. That's a pretty tight date range. And what's cool about that is that we have Wapato from a site over by the radio station in Burns. There's exactly the same date. So we have people using Wapato at both of those places at 10,000 years in age. And then we have, these are some of the more recent dates from those plant dating processes. Rocks. So the rocks, when I talk about rocks at the site, I'm talking about mostly what's separating the upper deposits of the rock shelter from the deeper deposits. And so again, the plants were found that were radiocarbon dated were between 4,500 and 10,000 years ago on top of the rock layer. Down below it, we have the older stuff. So the primary places where we're getting the old stuff is Unit 2, which was dug up until 2012, Units 30 and Units 18 and 19. I didn't include 30 because that's kind of an ongoing thing, and I've already talked way too much, and that would carry me way. I would hope you'd brought sleeping bags for that. But so here's Unit 2. This is the area of that unit we'll be talking about. This is Units 18 and 19. So now we're getting into the old stuff. When I talk about the rock layer that separates the upper deposits from the older, these are the kinds of rocks that we're peeling out of there. So we started in 2012, we started hitting the top of a rock layer, and it didn't look like bedrock because it didn't have the oxidization, that kind of orangey appearance, or it didn't have the chemical characteristics of what we would expect to see on basalt bedrock at that depth. So we thought we should take a chance and bust some of those rocks out and see what was underneath it. And fortunately, we had a guy that came and helped us, and he was an expert at busting big rocks. And he had a cadre of young and enthusiastic and students that were willing to lift those out of the pit. So he just went to town, and this is what it looked like after we got all of the rocks busted out of Unit 2, and we're working underneath it. So you can see some of those rocks here around the edge of where they're excavating. There's chunks of them still in the wall there. But what happened is when we got through those rocks and got down into an orange, oxidized, sandy clay layer below there is when we started finding the old stuff, really old stuff, 8,000, 9,000, 10,000 years. Once you get into 5 digits, that's nothing to sneeze at when it comes to our archaeological dates in Oregon. But here we start to see something just a tad bit different. So that's in Unit 2. And then over to the west, about 3 or 4 meters away, this is Unit 19. The rocks are smaller and they're more kind of latticed in there, but this shows Unit 19 at 220 to 225 centimeters below the surface. All of these rocks have been cleaned and mapped and photographed, and all of the artifacts and the chunks of wood and the bone and hair has all been collected in situ or in place. Each layer is 5 centimeters or about 2 inches thick. And then we are going through that 5 centimeters after another, mapping these rocks, going through. And this is what it looks like at 220 to 225 centimeters. So over there on the east side, there's bigger rocks that are just massive, substantial boulders that are located in here. Here they're broken up a little more, but they're more concentrated. And then this is 265 to 270. We're starting to break through all of these rocks and get into more fractured stuff with pockets of sediments underneath them that, in this case, we have a piece of bison tooth right there. And we're starting to find more open area to excavate as we get closer to bedrock there. So the point of these is just to show you that there was a lot of stuff, a lot of rock sitting on top of the oldest deposits at the rock shelter. But as we got underneath it, we were finding stone tools and chipping debris and big chunks of bison, horse, and camel tooth enamel fragments. And here's some of those. So what do you need to get an AMS date? This is a head of a needle and a poppy seed. That's just one poppy seed, but it takes about the same amount of enamel to get. It takes 5 poppy seeds worth to get an AMS date after all the processing and everything is done. This is enamel for radiocarbon dating. This is in a powdered form. Tom has provided what it looks like a solid enamel and what it looks like powdered enamel, and then another piece of solid enamel over to the right there. So that's kind of how it is getting taken out of the tooth and getting prepared for dating. Here are the different layers of enamel, the cross-section of the bison tooth enamel that he's working on, and some of the issues related to possible contamination, where he is selecting how to get the enamel that he's going to use for AMS dating. And then this is what that enamel looks like before it's ground down and cleaned and prepared for the sampling process. So these are big chunks of tooth enamel. They're fairly thick, but in terms of getting the sample that you need for radiocarbon dating, this is very fine detail work. It takes a really specialized technician to get the samples that you need for the dating process. And then this again is that table showing the dates with the plant material up above, rock fall separating the older stuff down below, and the dates that go from 11,000, or actually 13,000 calendar years down to 18,000. For reference, what has been found at Cooper's Ferry in Idaho by Lauren Davis and the OSU crew, they've got 16,000-year dates on that site. What U of O and Dennis Jenkins and other part of the field school was doing at Paisley Caves, they have dates of 14,500. So these are just a little bit older. And we've got our first dates in 2015. And then there was some difficulty in getting more material processed for dating. So it's taken up until last year, 2023, to correlate all the dates so that we can talk about them in publication. So it's been crazy how long it's taken for us to get there. But so the AMS sample sets, we have plant dates from 2011 to 2016. And then we have set 1 and set 2, different dates for redating some of the same objects, dating different objects from the site to see how close the dates match up. And this is just a rundown of the 6 different sample sets that we have utilized for that. All that amounts to is about 10 AMS dates on tooth enamel, because that is one of the few things that we get at the site that's preserved well enough to date. And then so what this shows you is that the dates on the camel tooth enamel are, we have 3 that date between 18,000 and 18,650. We have dates on bison between 17,000 roughly and 18,000 years of age. And then in units 2 and 30, the combined camel and bison dates are all in the 18,000s, and in Unit 19, the dates are all in the 17,000s. So we have, in those two different areas of excavation, we have dates that are consistently in the 17 to 18,000 year time range, but there are also dates that are separated by 500 to 1,000 years in some instances. It's old, it's buried under rock, and it's consistent. So that's the important thing for talking about, do we have evidence of hunting at 18,000 years ago in the northern Great Basin? And then the reason I pointed out that orange chalcedony flake tool to you is that when we were first excavating in 2012 in Unit 2, we broke through the rock layer, and just underneath it, we got a layer of Mount St. Helens volcanic ash at 265 centimeters below the surface. At the time, we thought it was Mazama. So when we brought it back, that sample, and checked it with Nick Foyd at Washington State University, he told us it was from Mount St. Helens, and it was from the eruption of 15,600 years ago, which was mind-blowing because it was twice as old as what we were expecting. As we dug a little bit further below that, we got into the camel tooth enamel fragments. There's a big chunk right there. We had 27 fragments of that. And then underneath that, we got, at another 10 centimeters of depth, we got that flake tool. So the tephra was at 15,300 to 15,600. This tooth enamel from this camel was dated to 18,300. And then this chalcedony flake tool was underneath that. So if the deposit is all intact and everything has been in place since the time it was left there, you know, it's like a pile of clothes. The clothes you wore on Monday is deeper than the stuff on Friday. In this case, if everything is in its right place, then that flake tool is older than that camel tooth enamel. So that suggests it might be older than 18,000 years, and that's a big deal. So here's some pictures of the tooth enamel. There's that camel tooth in someone's hand. And then Edward Davis at the U of O, I brought that tooth enamel over, and we went over to the Condon collection and looked at the, this is a camel mandible fragment, and that tooth enamel matches up pretty well with that, and it's not bison, and it's not horse. So what happened, so we had a pretty strong idea that that tooth enamel was from a camel because it was the right size and it visually looked like it belonged with a camel. But what we've done recently, and what I hope to talk about, put some of this aside and talk about more tonight, is the fact that we've been looking at the proteins, the peptide analysis of this tooth enamel from teeth that have come from the site. And there's a fellow named Glendon Parker who has been doing some work for us. And he trained forensically to identify infant tooth enamel from crime scenes and identify whether it was male or female. So with expansion of his skills, he can also tell what tooth enamel, what family of animal the tooth enamel is coming from. And he verified that that is from camel and that it's from a male, which is fairly cool. And the one sample that we sent to him that we thought was bison, to test whether or not we had, you know, to verify that we had bison at the site, because some of these fragments look like they could be, these are all from where the camel tooth came from, but some of the bison tooth enamel fragments look like they should be bison, but we wanted to verify. And that one came back as horse. So we have bison visually identified. The one sample we had was horse. So we have bison, camel, and horse all from 17,000, 18,000 year time range at the site. And so here's that camel tooth enamel once again. I'm going to blow by that. But in 2023, on the last day of excavation in Unit 30, we got a piece of tooth enamel. This is from a Camelops incisor, minus the root. And this is it next to a bison incisor from a 1,200-pound bull. And this is just an elk incisor. So very last day of excavation, we busted out a big chunk of rock, got underneath it, and found this big incisor. And we have a date on that is. What's that? Well, these are from my comparative. Those are from my comparative collection, the bison and the elk. But this camel is from excavation at the site. The students that found that, it was all student labor that identified, got the rock out, got underneath it, found that incisor, and that was a great day. Yeah.
The rock fall.
Yes.
So as you move further away from the rock shelter, so further away from that rock belt, is that only the earlier site that is, like, as you move into the marshland? The way that I'm thinking about it is you have the rock rim, and as you're moving away from the rock rim, are you moving forward in time?
We have dates on some bison tooth fragments from out further away from the rock shelter towards the stream channel that are in the 13,000, 12,000 year range. So yeah.
But still before that.
Yeah, yeah, that's true. Because we're only selecting the tooth fragments that are from the old. Yeah, it was well worth it. Yeah, it was very hard work. Those kids were really dedicated. So here's some camelid enamel. You've seen that before. Here's some bison enamel. In Unit 2, this camelid enamel is coming from 263 to 275 centimeters below the surface. Over in Unit 18, this bison enamel was 263 to 265. So the sediments with those deposits are matching up. The dates are 17,000, mid 17,000s, early 18,000s over here in Unit 2. Here's some more tooth enamel from various portions of the buried portions of the site. And then we did a couple of tests to see whether or not the dentin or the material in the center of this tooth fragment would date the same as the enamel. And what we found out is that this is more porous, and it produced a date of 10,860. The enamel produced a date of 12,225 radiocarbon years. And that's the only, I just want to show that there's a difference between what we're getting on the enamel and what we're getting on the dentin that's more porous and absorbs more exterior material. This is another test that we did, and in this case, we removed this original surface of the tooth of manganese off of the surface of the tooth enamel, and then did the original surface and with the manganese removed, and the difference in the dates is negligible. The material that has the tooth enamel, or that has a manganese covering, is 12,525. With the enamel, or with the manganese removed, is 12,545. So that didn't make much difference. Blood residues was another thing we looked at, and we have blood residues that are coming from horse, bovid, in this case bison, mountain sheep, and then some that didn't produce any blood residue. So we have not only horse verified by actual peptide analysis, but we have blood residue on stone tools from horse too, as well as bison. In Unit 18, or in Unit 19, we had this. This was that chalcedony stone tool that was in Unit 2. In Unit 19, we found another flake of that, big flake of that material that had been modified into a tool. And then in Unit 2, we have this kind of disc-shaped scraper that has bison blood on it. And this one here is here, and it had bison blood. And this is a similar tool form, and that had horse blood on it. So we know that people were using these big flake tools to process bison and horse. We haven't found one that has camel on it yet. And then the latest. So I'm not going to spend any time on this, but what I've tried to show you is that we have similar types of stone tools and similar composition of stone that's showing up in Units 2 and Units 18 and 19. We have large mammal enamel concentrated at lengths between 263 and 275 centimeters. Bison bone and utilized flakes. All these things are associated with Ice Age animals. They're showing up in Units 30 and 2 to the east and Units 18 and 19 to the west at the same depth. So I'm just rehashing things that I've already talked about. So why were people here? Rimrock Draw is a place that shows human activity between the end of the Ice Age and the eruption of Mount Mazama. There was lots of flowing water there 18,000 years ago, and small stable marsh between 13,000 and 7,500 years ago. And then when Mazama torched off and left a deposit sitting on top of those marsh clays, appears that it changed the condition of the landscape or the availability of water. And we don't see water coming through that channel anymore, and we don't see people coming to the site anymore. So despite the proximity of Glass Butte, people stopped coming when the water disappeared. So this is a list of contributors. There's been a lot of people involved in this process, and a lot of funding has been provided to us for the work that we've been doing. Archaeology is never a solitary endeavor. It's always something that's a collaboration between the people that are doing the work, field school students, volunteers, various funding sources. It's just been a massive project with a lot of hands in it, a lot of support from various places, and this is a list of those people that are involved right here.
Does anybody else have any questions for our guests?
There's the crew from the 2021 field season, rough and ready. And that's it. Sorry it took so long.
Looks like we got one question over here.
So because of what you found there, is it the understanding that it was just a place where people kind of came and hung out and hunted and moved through? They didn't live there? Or are you still looking for exactly what was going on there?
So the question is, was it a place where people just passed through and lived there temporarily, right? Hunting, plant processing. Archaeology is based on physical evidence. So we try not to extrapolate to what people were doing beyond what we can see in the physical deposits. And so we know that people were eating plants. They were using plants that are historically documented for utilitarian purposes. They were using medicinal plants there. Those are preserved in the deposits above the rockfall to an age of 10,000 years. So we know that there's plant use there. We have tools that were there, or that are there from when people were hunting or processing bison, camel, and horse. And my sense of the place is that it was some place that people came to on a regular basis, but didn't live there for a long time. when you see an archaeological site that's been used by a lot of people for a long time, there's a wide diversity of stone tool types or other tool types that are there. And we see a few craftsperson's tools there, those really specialized tools that are deep below the rock layer. But most of what we see is stone tools that could have been used for hunting or for knives or for, you know, drilling holes in leather or whatever. So my sense is that people were passing through there and staying for some duration if they got an animal to chew on for a little while or something, you know, but I don't think it was a place that was used extensively for an extended period of time.
I have another question up here.
With the camel enamel, is that how you guys tell when a animal goes extinct? Because camels went extinct for a long time until they were brought over from Europe. So when you guys get that enamel and it shows that date hits 13,000 and there's no previous dates like closer to where we're at, is that how you guys like track it when the extinction happened?
So archaeology is like paleontology, where we're tied to the physical evidence. And so when we're trying to determine how long an animal has been on the landscape or how long people have been on the landscape, it's through the ways that we can date those objects or that material, like from the tooth enamel. So with paleontology and archaeology, you're looking at the extent of pieces of tooth enamel or bone or other material that's been dated from those animals, or deposits that are indexed that hold those bones in it. So I think that in terms of age, the most recent age that camels were on the landscape was about 11,000 years ago or so. But it's, you know, it's where you see those dates and when they stop. And that's why it's so important to with archaeology and paleontology. You want to date everything that you can, you know, and you want to put those dates together and search the literature to see who else has done what and where they're getting dates, and somebody sits and synthesizes all of that stuff over time to determine what the latest series of, you know, the latest date range is for a particular animal.
Online, we had a question that said, excavation gone to bedrock, Oregon, can it go deeper than it has been dug?
Can you repeat that? I'm sorry.
Has excavation gone to bedrock, Oregon, can it go deeper than it's been dug?
In units 2 and in units 18 and 19, where we're getting the oldest dates, we've taken those all the way down to bedrock. There's a few other units where we dug down to bedrock, but there's a number of places that we're trying not to do any more excavation in. So we've done a lot of work. We've excavated a lot of dirt out of that site, but we've also tried to preserve a lot of the deposits for future researchers, or just so that site continues to exist. So yeah, we've hit bedrock. Thanks. We've hit bedrock, but we haven't dug the bedrock everywhere we put it in.
Does anybody else have questions here? Oh, sorry, I almost missed you.
It's rustic. So when we've done field schools out there, yeah. Yeah, so we have a hillside that has trees on it, so there's shade. And then we bring out some T-posts and sheets of plywood, and we put up some windbreaks, and then we have some trailers for storage of food. And people stay in tents generally, and they cook communally. So the students come. Every year there's somebody that comes out there, and they don't know what they're getting into, and they've got these really beautiful white tennis shoes that have never seen what they're about to see. and they hop out of the van and they plop down and their shoes hit that dust and it's like, oh my God, what have I done? And those are generally the ones that also go most feral by the end of the season. So yeah, it's just all camping. We're about 1.5 miles from the site that we work at. So we started about 7:30 in the morning, go down to the rock shelter and excavate, and then come back at about 4:30. People have the weekends off, but we have cooking crews for weeknights for dinners, and then we have a cooking crew for breakfast. Everybody packs their lunch. We provide the food. You know, it's just, and people settle in really well. So yeah, it's some of the more challenging conditions from time to time, but people tend to do quite well with it. I don't do field schools anymore, at least not in the form that I did for the U of O. But there is a field school that is going on currently through Caitlin McDonough at the University of Oregon, and she is working at a site called Connolly Cave. And I think, well, who knows this year, honestly, but I think there were plans for them to work out at Connolly Caves again this year and do a field school there. We have anywhere from, in the past, I've had anywhere from 6 to 35 students out there, and it's just crazy. And at our site, there's rattlesnakes.
Well, if you want to stick around and try to have some other questions answered, you can come talk to our guests here. I always want to say thank you so much for coming and listening to the lecture, and thank you to everybody online. There's been several people online and very nice comments too, so thank you for that. That said, thank you. Have a good night.
Thank you.